Hi, my name is Ben and I'm an engineer here at National Instruments. Imagine if somebody walked up to you and gave you $40, less than an hour, and said, I need you to make me a miniature weather station that records the temperature and light intensity of the room. Except you don't know any C code. This kind of stuff is possible through the LabVIEW Interface for Arduino Toolkit. What is the Arduino? So the Arduino is a little microcontroller platform, and you can think of it kind of like a little computer. It's got USB to connect to the computer. It's got digital input and output for doing things like turning little lights on and off. It's also got analog input for doing things like reading the temperature. And it can do more advanced functionalities such as I2C and SPI communications protocols. Also, all this comes for hardware starting at $30. The LabVIEW Interface for Arduino Toolkit was created so that LabVIEW users could read from and control the Arduino pins from a graphical programming environment. We wanted to give LabVIEW users the ability to make exciting projects quickly, inexpensively, and with the ability to extend the functionality of the open source toolkit if they needed to. So what does a basic system look like? A basic system has a computer here with LabVIEW on it, which is a graphical programming environment. It's connected through a USB cable to the Arduino. Keep in mind that the Arduino does have to be connected to LabVIEW in order for this toolkit to work. It's not a system which deploys code, for instance, to the Arduino. However, we can connect to it wirelessly through XBee or Bluetooth. But for this demonstration, we'll use good old USB. So to take a look at an example, we're going to read the temperature with a thermistor. And a thermistor is a sensor which changes its resistance according to the temperature of the room. So all we need to do is an analog read across the voltage of the thermistor, and we'll be able to tell what the temperature is in the room. So if we open up this example, which ships with the toolkit, it's called the thermistor read example, and you can see a simple graphical user interface here. On the left side, we can configure the experiment with things like which analog input pin we want to use on the Arduino, the units in which we want to read in the temperature, and also the paired resistance of the thermistor. On the right side, we output or indicate the temperature, and we also have a stop button to stop the experiment once we're done recording the temperature. So this is the user interface, but if we wanted to take a look at what goes on under the hood, we could go up to Window, Show Block Diagram, or simply hit Control-E to flip between the front panel and the block diagram. So this is what's going on behind the scenes. You can see here at the top we've got the code. In the middle we've got an explanation, some good documentation of what the code's doing. And down at the bottom we even have a wiring diagram. As you can see, I've got the same exact setup here on the table. So the Arduino toolkit uses the same open, read, write, close programming practice that a lot of good LabVIEW techniques do. So on the left side here, going from left to right, we're going to open a connection to the Arduino before going into the loop. Once we're inside the loop, we're going to keep reading that temperature with this VI in the middle, which is configured from the controls or inputs from the front panel. We're going to output it or indicate it to the front panel to the temperature. And then also this loop is going to keep running until there's either a error on the line or error in the system or the stop button has been pushed. Once the loop has been closed, we close the connection to the Arduino and check for errors. So if we go back to the front panel, we're going to take a look at what this looks like when it runs. At the top left here is a run button, and we're going to hit it. And as you can see, we are currently reading the temperature of the room. I'm going to go ahead and touch the thermistor just so you can see the temperature changing. So that was a basic example of taking a temperature measurement with the toolkit. We spent some time developing 80 VIs and over 600 lines of code so that you could spend less time on your total project, focusing more of your energy on the higher level system as opposed to worrying about the framework. If we forgot anything, everything's open source, so you can simply add functionality as you need. And lastly, we really look forward to seeing what you guys can make with the toolkit.